Okay, I can have seen 4 red reactions. Yes, then I would. Okay, there's 1 green reaction, but I think the majority of you has not had not have the time to have a look at these tasks, and that's why I would like to do the following. I will put you into breakout sessions with, let's say, we're 17 participants. I'll create 3 breakout sessions. So there's going to be 5 or 6 participants. No, it's going to be 5 because 2 of the 17 participants is me. So there will be 5 participants per breakout session. And yeah, I'd like you to gather in your group and yeah, think about the 4 tasks, 13R, ST, and U together. And yeah, maybe you will find a solution approach with which you can present to everybody afterwards. And yeah, of course, you also have the sample solution to check if your answer is correct. But yeah, I would like to also see your solution approach, and maybe another group will have another solution approach, and then we can discuss which one is the easier one. So yes, I'll see if I can create the breakout sessions. I think I'll give you about 5 minutes time for every task, or let's say we'll round this up to half an hour. So you will have half an hour in your breakout groups to go through the tasks R, S, T, and U. And afterwards, we'll check if you've come up with a certain or a valid solution approach. Is that all right with everybody? No reaction. There's a green one. Thank you. Okay, so I'll see if I can create the breakout sessions. 3 breakout sessions and create. Yes. So now you should be able to access the sessions. And maybe I'll enter the sessions in a few minutes. So I'll check if everybody, yeah, is working. What about you guys, the last 3 remaining in the main meeting? Can you access one of the breakout sessions? What about you guys, Tahir and Miguel? Are you able to access one of the breakout sessions? Of course, you don't have to, but yeah, I hope you have the opportunity to enter one of the breakout sessions.
It's easier. So perhaps we can just skip the ones there that we can already. How does that sound?
Yes, sounds good.
Okay. So give me a second. Sorry, I'm changing my laptop setup. Okay. So perhaps we can try doing. Which one do you have? Probably my mouse first for a second. Right, there we go.
Tahir or Tahir. Can you hear us, brother?
How do I pronounce your name?
There is another guy in chat. Tahir or Tahir.
Right, perhaps we can give me a second. This one is easier. Yes. So wait, I have a question. This
But-
symbol is the division symbol, right?
Mhm,
Like
division
one
symbol.
in.
Yes.
Okay. Makes sense.
So
Right.
should we try R? So I think he
Right.
said
Okay.
R to
U.
yes.
R to U, right?
Okay.
Kevin, do you use any tools? I mean, any pencil or something to write right now?
Me?
Yeah.
Yeah, I'm using a stylus.
Perfect.
Okay. So perhaps we just do the obvious one first. We just switch.
You wrote 15 xy.
Sorry?
You wrote xy root of a minus 1 or
Yes.
I
A minus 1. One second.
I mean,
Which one?
yeah. Is it 15 y root of a minus? Or
Uh,
why did you
Nah.
add x?
oh, sorry. Careless mistakes. Thanks for pointing it out. So we just simply multiply these.
Mhm.
I see, but in the on the page he gave to us, there's 15xy a minus 1 rise. I think.
Yeah, correct.
You see, I think you forgot it in both terms.
Sorry?
On the task, it's written 15xy square root m minus 1. So
So you were
That's where
right.
that's why I wrote that. Okay, sorry. All right. Thanks for correction.
thanks, Kiel.
Welcome.
So what are we gonna do right now? I'm sorry, guys. I didn't prepare for this, so I'm just watching.
Okay.
Have you? What is there anyone who has taken these courses before in their study
No.
life?
Nope.
Kiel?
No, me neither.
Mm.
Oh wait, that's squared over.
Welcome, Kule.
What's going on? I just joined the class and saw something about a breakout session.
Yeah, Simon put us into the groups so that we can share our ideas and try to make a solution together. So that's why we are in the third group or something. I forgot the group name, but yeah. We are just trying to solve the task 13. Yeah.
Sure.
Kevin, I can't hear your voice if you're talking.
Oh, no, I'm not talking right now.
Oh,
Sorry, I was just mumbling a little bit. Oh wait, perhaps can we like add somewhere so we can chat about perhaps also stuff outside of maths, like for example, the German bureaucracy, and stuff. For example, any of us comes late to the class and like yeah, so we can share information and all. How does that sound?
yep. But before we talk about the brokers or something, can we could you?
Just polling.
Yeah.
Okay. Kevin?
Yeah.
While you are solving the problem, maybe could you a little bit talk about the solution, or just maybe you could teach us a little bit?
Okay. So, which
Like,
part of the question don't you understand?
third part.
Third part. So, is it this one?
Yeah, right.
That one. So, first we have x to the power of 1 on top and x to the power of 3 on the bottom, right? Like, let me rewrite the question. All right, can I like share a different screen? The Zoom whiteboard is actually pretty bad. I can barely like write anything. Give me a sec, perhaps I can share. It's not responding.
I didn't expect that we are going to solve the problems together. Uh, Did
Mm.
Simon mention yesterday? Because I wasn't in the class
I don't
at
think
least
he
last
mentioned
40
anything.
minutes.
Actually. I don't think he actually mentioned it.
Hi, Simon.
Hi. May I just
Hello.
ask you how you get along with the task and this, with this kind of group work?
To be honest, I didn't expect that you were going to give us a task like that. I mean, I wasn't prepared.
Yeah, no problem. So it's no problem if you don't have a digital pen or a digital device to write on now. That's why I put you in groups with 5 people. I was hoping that at least one of you would have a digital device where he or she can write on, and that the others can just throw in ideas about how this task could be solved. And because I have to work on the tasks by myself until so it would be better before I show you a proper solution approach for the tasks to get through them for me as well. So yeah, I use this kind of way to get myself some time. But yeah,
We were
it's
discussing, sorry, 14, task S right now.
13S.
Sorry, R.
13R.
Oh, yeah. So here we have like. Let me change the size. There, it's much easier to write here.
Yes. Yes, I can hear you. Yeah, it's still a little hard to understand, but it's okay. I can hear you.
Okay, so just now, who was the one asking?
I was the one.
Yeah. Okay, so far, when you see like this, perhaps let me expand the bracket. Grab the eraser. Where's the eraser?
Okay, I'll get you back to the main meeting in 8 minutes from now, and maybe you will have a proper solution approach for at least this subtask then. But yeah, it's no problem if you don't have one, because we'll go through all the tasks with the other groups too. And yeah, just
Okay.
just keep working for the next 8 minutes, and then we'll see what comes out. All right, see you.
See you.
Okay. So you see we have like 20 and 60, right? Sorry. 20, so 20 and 60, it can be divided by, both can be divided by 20. So to get here, become 1 and 3, right? And then you have x and x cubed. So x over x cubed over x squared cancels out. And then we have y to the power of a, they both can cancel. And
under the 5 times y squared a, the 2x a squared, right?
sorry, the one, this one?
Yeah, I got it. Sorry.
Okay. So as for 1 over y to the power of -1, it will become y, right? Or to make it more clear. So we basically move it up. And as for the a, we don't do anything to it. So yeah, well, that's how we arrive at the last solution. This is the y that we moved. And the x square and a square that is left over, and then I put into bracket to simplify it even more. Perhaps we can do something else.
Okay, I can see what you've done. So I wrote it for me down, and so I'm okay with that. So I understood the task.
Perhaps we can
So-
do, yeah. Anything you have problems with? Perhaps let's try 14W. Sorry.
Yes, sounds good.
What was the answer for 13R?
Oh, let me open. Wait. A sec.
So where did you found the task paper? So he had in the beginning of the meeting. Is it on the VMint website, or where can I find that?
It's on the VM website.
Yeah, where did you found the questions? So the piece of paper there.
Via Mint.
VMint and
Day 3.
okay.
Pronunciations and roots.
Okay, thank you.
You're welcome. Kevin, are you talking?
No.
All right.
Trying to solve this. Let's see.
So 45 divided 2 plus 18 divided 2, right?
18, there'll be 50. No, sorry. 60.
63 divided 2.
Right over 2. And then we have a cube root, so
Mm-hmm.
cube root so 3. And then another plus 2. And then 5, right? 6. Perhaps I'll put these out first. 6. So, five.
Yeah.
Five over two, right? That means
Yeah,
we have
seems right. So x squared 5/2, right?
x.
X.
No, sorry. Okay, like that.
You don't need to put 2.
Sorry.
You don't need to put right 2 square. Yeah, I mean, just make a square. Yeah, I mean, yeah, okay.
Yeah.
It's good.
All right. So,
You could just draw the square symbol. So that's why I,
square symbol.
yeah.
Oh yeah, right. Right. But anyways, let's just use the index form because it is simpler than the square form. You meant like we can write it as like this, right? Yeah.
Mhm.
I totally forgot about the square.
Oh.
So 6, 3, that'll be 2.
One is the same position. No.
4. Oh, room is closing. Now, so let me just do this quick. I equals to, right?
It's better to watch Simon.
Okay. Well,
I
let's see
mean,
you in the
yeah,
main meeting
you
room, I
did
guess.
perfect, brother. But I mean, we aren't prepared for this. That's why we
Yeah.
are having difficulties.
Yeah.
Yeah.
All right. See you in the main room. Oh yeah, right. We could use you more. Yeah. Okay. See you guys.
See you.
Okay, I hope everybody's back in the main session. Before we are addressing the tasks, I just received an email from Mrs. Reinking because I texted her because of some questions which came up on Monday and Tuesday in here. I don't know if the ones who asked them are in the meeting today, but yeah, she offered to join us on one afternoon. And that's why I want to ask you if you would like Mrs. Reinking, so again, she's the international student coordinator, if you would like her to join our tomorrow's session, then you could ask her some questions about your studies in Hamburg at the HW, and she knows a lot more than I do.
Yeah, I think that would be really great.
Any other?
That would be great.
One? Yes. Okay. Then I'll ask her if she is available tomorrow in the afternoon for our meeting, because I think tomorrow's topic should be logarithms, and yeah, I don't think that we'll need all our 3 hours of time for this topic. And yes, then I'll answer her email later if she's available for tomorrow afternoon. So everybody should think of questions he or she may want to ask Mrs. Reinking. Yeah, of course, she also sent the answers to some of the questions I sent her, but yeah, okay, just see that the main answer is ask someone else. Okay. Okay, there's no very clear answer to one of the questions. Anyway, she'll join us tomorrow, hopefully, and then you can ask her again, or yeah, I'll ask the people she suggested me to ask in favor of, for example, the graduation rate. She wants me to ask Professor Lapke. But yeah, I'll do this, and she will hopefully join us tomorrow for every other organizational question concerning your studies. All right, yeah, back to topic. Let's proceed with our task set number 13. Tasks are S, T, and U. Yeah, how did you get along with the tasks until now? So you got half an hour of time so far. Which group was able to, let's say, solve at least 2 of the tasks? Was there any group able to solve 2 or more of the subtasks?
Yeah, we are in room 2, so we have completed 4 of them.
Oh, you've very good, completed all of them. So I'm not going to have a lot of work right now. So because you will show us the right way to approach these problems. Are you somehow able to show us your solution approach for task number 13R?
Yeah, I can show you, but it was like a rough work, so you might not be understanding properly.
Then my proposal would be that I am writing it down again and you tell me what to write down.
Oh, okay, that would be good.
Okay, so I hope you can see my OneNote right now.
Yeah, it's visible.
Yes, very good. Okay, so what was your first step in order to solve task 13A R?
First of all, we flip the 5y to the power a upper and then 2xa whole square lower.
Yes.
And then multiply it with the first 2 term. Yeah.
Yes, so this is one of the most important rules when dealing with fractions in general. So if you have a division of 2 fractions, or at least a division by a certain fraction, then the rule is like the following. If you're doing something like a b divided by c d, then this is just the same as ab times c, times the reciprocal of the original fraction. So you just flip the numerator and the denominator of the divisor, and you'll end up with an easier operation because hopefully you're all able to multiply 2 fractions. Okay, so we'll do the exact same thing when solving our task 13R. In this case, this will leave us with 4x to the power of a plus 1 divided by 15xy to the power of a minus 1 times 5y to the power of a divided by 2xa whole squared. You got this in this way too, right? Was this your first step as well? I don't know who was talking. Yeah, okay, there are green reactions.
Yes.
Yeah, okay. So what's the next thing to do about this term?
Then I x to the power a multiply into x to the power 1 or only x, because there is a plus sign 4xa, that term I'm talking about.
So you are talking of this one and this one?
Upper one.
Upper one? Oh.
Yeah.
Which one? So just the one which is circled right now, encircled right now.
Yeah. Oh,
Okay.
I wrote it down like 4xa multiply into only x.
Yes, that's of course a thing you can do, because
Yeah.
x to the power of a plus 1 of course just means x times x times x times x for a times, and x to the power of a plus 1 would just be the same with 1x more. So this would be x times x times x times x and one more of them. So this would be a plus 1 times. And that's why you can see that x to the power of a plus 1 definitely needs to be x to the power of a times x. All right. Okay, I'll have to write down this other stuff again. What is next? The next step?
Then I wrote 15xy.
Yeah, just keep talking. I
Okay.
listen to you.
15xy to the power a into 1 by y, because there is a minus 1.
Mm-hmm.
Y, the power of y, there is ya and minus 1. That is why I wrote it down 1 by y.
All right, so I'll just do this with another color. So you're now looking at this term down
Yes,
here.
Yeah.
And this is y to the power of a divided by y, correct?
Yeah.
So like this.
Yes.
Correct. So what is the next step?
Then I put the lower y into the upper x, like upper nominator, maybe the term called like the lower y will go the upside.
So the numerator.
Yeah, numerator.
So you did something. Of course, you can write this on one big fraction dash times 5ya times y. So if there is someone in the meeting who cannot follow our derivation here, please feel free to speak up. Okay, so what next?
Then 2xa whole square, we like split it up, right? 4x square a square.
Yes, that's correct. So you're now looking at this part of the term.
Yes.
And this is going to be 4 times x squared times a squared. So now we have 4xa times x times 5y to the a power of a 15x times 4 times x squared times a squared. All right.
Then I canceled out 2, 4. Then 5, I divide 15 by 5, and the answer will be 3. And then canceled out the x, both x, upper and lower.
I have to do it in other colors, just a second. Yes. Which ones?
Both x. Yeah.
X and x.
15x. All right. Then y to the power a and y to the power a.
I'm running out of colors. Y to the power of a, y to the power of a.
Yeah.
So okay, let's write it down again. What is left now? So what is left is x to the power of a times y divided by 3 times x squared times a squared.
Yeah.
Okay, anything else we can do about this?
Yeah, then we put x square into the nominator and it will become x to the power a minus 2. And
Yes.
the lower part will be 3a square.
Okay, let's do one intermediate step about this, because the rule which tells us that this is correct, what you just said, is the following. Because we have 1 divided by x squared in here. Can everybody see this? That there's a 1, an imaginary 1, and then we have 1 divided by x squared in this term. And one of our rules about exponentiations tells us that this is the same as x to the power of -2. I hope everybody spotted the overview of all the exponentiation and root rules in our material folder. I can show you this overview in a second. Yes?
Yeah, I did spot this, but I don't understand what is the point of converting 1 over x squared to x power -2, since there's nothing to cancel it with, for example.
Yeah, okay. We'll see if there is something to cancel it with. Because this 1 over x squared now is showing up in the numerator as x to the power of -2. Yeah, okay, times y. And yeah, so now there's another rule of the sheet which can be applied, because we also had the rule which is like, let's use other letters, a to the power of b times a to the power of c. What about this? What was the rule about this? Or the rule?
We're going to add the 2 powers?
Yes, the 2 exponents will be added, like b plus c as the new exponent to the same base. And for our example task, this means that the numerator will develop into x to the power of a minus 2 times y. Okay, is that clear to everybody?
Yeah, I got it, thanks.
Okay, very good. All right, this is the solution from the sample solution sheet as well. So it seems like it should be correct. All right, any question about this or any other solution approach which may be faster?
I have a question. In the university, do we really do such tasks? Is that part of our syllabus?
Well, sometimes you may have to do it, and of course not just with x and a and 1 and variable names, but it's always about practicing the principle. And when you are dealing with, for instance, electro technology, so electrical engineering tasks, let's say you have to calculate certain currents or voltages in electrical networks, then you will have to do a lot of what's the word for it? Reforming. No, reforming is not the word. Just a second. Reshaping, conversions of terms. So I think later in the preparation course, there will also be some tasks with electrical engineering relations. So you will have tasks which really have a practical usage or practical use case. But for now, it's just about practicing the principle. Okay, and of course, in your mathematical lectures, you will have to do this again. All right, what about task number 13S? Maybe there's some other group. Is there any other group who has a solution approach for task 13S? Otherwise, group 2 would have to go again.
Simon, did you say something?
Yes, I asked if someone has a solution approach for task 13S.
Yes, I do. Should I?
Yeah,
should
you
I
may.
tell you how to do it? Okay.
Of course.
So at first, what I did, so I worked with the denominator, and the denominator could be turned into a plus b whole square into that rule. So at first I turned, yes, I can use that rule there. Okay, so I can turn 4x square into 2x whole square. Then it will look like a square there. Yeah, so I'll turn that into 2x whole square.
Okay, so let's check if, what did you say, 2x?
2x
Yes.
whole square, yes. Whole square. First whole square. Can you add another bracket next to? Yeah, we can do that too. Yes, actually.
Oh,
yeah,
sorry, did I do anything else?
No, it's not. I did that exactly, but like I wrote another extra line instead of writing that like that. All right.
Okay. What did you write down? Let's write down what you wrote.
I just wrote 2x whole square plus 2 into 2x into y plus y square, then again whole square to the whole, then again whole to the power 6. But
So,
you did
like,
it, you used the shortcut path. That's
okay,
okay.
I think I used the shorter way then, because
okay.
I spotted that this looks quite similar to what is the right part of the equation of the first binomial formula. And yeah, of course, always if we spot something like this, we can go for a try if this may really be one outcome of a binomial formula by just trying. Okay, so if we want to try, we'll have to draw the root from this one in order to get our first summoned, and we have to, so just a second, the root of this one, and then we'll need to draw the root of this one. The root of the y squared term, of course, is just y. And then we'll have always, I already told you this yesterday, we always have to check if this is true, because we have not at all considered the task in the term in the middle, the summoned in the middle. And of course, we have to check if this all turns out to be true. That's why we are doing the counter operation. We'll just do the expansion of the brackets. And this gives us, of course, 4x squared, because that's where we came from. Then we'll have the term in the middle, and this is going to be 2 times a times b, which is 2 times 2x times y in this case. And the last one is, of course, going to be y squared. And as you can see, 2 times 2, of course, is 4, and that's why we'll have 4xy in here. And this shows us that this is a correct operation. All right, so what can we do now? We can write down or rewrite the original term the following way. Of course, the numerator stays the same at first. And what about the denominator?
So now the denominator would be 2x plus y to the power 12.
Okay, let's do it like this at first.
Yeah, yes.
Always be careful to use as many parentheses as possible, because if you don't, you will make a lot of mistakes when transforming tasks or converting displays of terms. Okay, so what's the next thing we will do? You already mentioned it. Yes? So you mean that just like I did it, right? Because I used parentheses for once and then for a second time. So I know that in some countries it looks like this, then they use this, then they write down something, and then they, yeah, okay. In Germany, it's completely fine if you always use parentheses. So this is no problem in our country. So just, yeah, maybe some professors will do it in a way that every parenthesis, which is further on the outside, is getting bigger. But yeah, actually it's common to just use parentheses and not these kind of braces and brackets. Yeah. Yeah, they are, but actually we don't like to use them a lot because they may be mixed up with the braces, for example, for sets. Because as you already know, if we are talking of sets, then we also use these braces for giving a set of, for instance, natural numbers, which was, as you remember, 1, 2, 3, and so on. And in this case, we have to use the braces because this is yeah, a definition how you write down a set. And yeah, that's why we actually never use these in yeah, equations or terms, mathematical terms. The brackets, however, they are used sometimes, but just by some people, some professors. But the most professors will always use parentheses. Okay, so what's the next step we could do?
So next we can since we can see that, as we can see that the both of this what they call it, like equations are same, so you can just subtract the denominator's power from the numerator's power.
Yeah, but at first you have to connect these two, right?
Oh, so I already mentioned it before.
Yeah, you mentioned it, yes, but I wanted to write it down. So numerator stays the same again, and then we are applying another rule from the rule sheet. This rule now told us that, let's make this a new box. So the new rule is that if you get something like x to the power of a, and this whole term is raised to the power of b, then this is the same as x to the power of a times b. So in this case, this leads us to 2x plus y in brackets, and then 2 times 6 is 12. Yes, and now we are nearly there. What are we going to do now? You already said it. We have to use another rule. I don't know. Yeah, I already wrote it down, basically. Okay, of course, you could extend this box to the case that a to the power of b divided by a to the power of c. And in this way, of course, or yeah, not of course, but it's quite logical that it works the other way around. So with b minus c in this case. That's why the final result is going to be someone?
Yes. The final result would be 1 divided by 2x plus y whole to the power 4.
Yes. Okay, let me write it down in another way first, because we want to use, or we want to apply our rule exactly like it is here. So if we subtract b minus c, we'll get 8 minus 12, which is negative 4. So I'll first write down 2x plus y to the power of negative 4. And another rule we already wrote down, this one tells us that this could also be displayed as 1 divided by 2x plus y to the power of 4. So I understand if some of you may say that this is a more compact way to write this down than this, but actually most of the mathematicians and most professors prefer to have this display of the result because they don't like negative figures in exponents. And yeah, so it's quite common to use this way of displaying such a term. Okay, I think this should be the same result as in the sample solution. Yes, it is. All right. Yes, any question about task 13S?